So we're going to introduce functions today, and we've been working with equations, and they're kind of like a function. Most, if not all, equations are functions, but not every function is an equation. So a function is just a special thing that we're going to be using. Mathematicians and scientists developed it because we need to be able to talk about real-world things in different ways. So if I'm walking down the street, I want to talk about my displacement over time, not my x over my y. It just doesn't really make as much sense. On top of this, functions have some special rules and we'll talk about them. So our goals for today are to be able to understand what exactly a function is and to be able to recognize a function based off of something being put in front of us. So here's our basic thing of a function. A function explains the relationship between an input and an output. So there's three critical things here. We need to have a relationship between two things. It has to have an input and an output. And so we're relating our inputs to our output in some way. Here are some examples. Y is equal to x plus 1. Now this is an example of a function. Even though it doesn't follow, it is an equation because it's equating two things. But what happens is we plug in x, and whatever number we're going to plug in for x, it goes through this magical machine, like over here. We plug in x, it goes into this black box, and it comes, actually this is a blue box, and it comes out and it spits out something different. And that thing that it spits out is y. Here we have y is equal to x squared. The same thing. We're going to put in something, which is our x. We're going to put it into this function, which is our relationship. It's saying you need to square it, and then it spits out something for y, and that's what we're getting out. Now here's some terminology. We have things that you might hear about these a lot in science as well. We have our independent variable. So this is the variable that you can change. It is independent of anything else. It doesn't care what you do to anything else in the equation. It's just going to be happy the fact that it exists. The dependent variable is the variable that is changed by what you put in. It cares very much as to what you're putting into the equation. The independent variable, plug in whatever you want. It's the input. Our dependent variable depends on what you plug in. It's an output. If I put something into my 3D printer, it doesn't matter what color of filament of plastic filament I'm putting in. The output, if I'm using the same code, will always be the same. The color might be a little bit different, but the output is going to be the same thing. If I'm making a boat, it doesn't care if it is black, blue, silver, green, purple. Going into it, it will come out as a boat in the end. Here is a way that we think of it. Y is dependent on x because it changes according to where you are on the x-axis. Remember back to our y is equal to x plus 1. Y, it doesn't matter what you're going to plug in here. X doesn't care. You can plug in -10, -50, -100. Y, though, actually is equal to whatever's happening with this relationship. It is dependent on what you plug in for x. And we're going to go and think about functions again. And here we have our little function machine example. And you can think of functions like a machine. You put a material in, like these apples, it goes into this magical box and it goes through this relationship and you get a product out like these apple slices. What you get out depends on the machine. So this function, h, and functions will have names like f and g and h and whatever we're going to call them. This function h takes our raw apples and spits out apple slices. It requires that you put in apples of some form to get out these apple slices, and it will only do this. You can't put in oranges and expect to get out apple slices. You also cannot put in apples and expect to get out grapes. The apples get sliced by this machine and it spits out apple slices, and that's what this one specific machine called H does. Some real-world examples are going to be a washing machine. You put in your dirty clothes, it goes through a process and it spits out clean clothes. A 3D printer is the same thing. You put in filament, it goes through a process, and that process is guided by code that you put into the machine, and it spits out a thing, like a vase, or a cat, or it looks like a dinosaur in here. Code is another really good example of this as well. You have to, like, when you build something for code, you're saying, if I plug in this, I expect you to do this. So like if I click on this icon, I expect this folder to open up. You have to go in and say exactly what happens, and you're not expecting it to be like, I clicked on this icon and suddenly some other random program opened up that I did never click. My last example here is our coffee maker. You put in coffee grounds, it goes through a process and it spits out coffee. These are all real-world examples, and for our quick check, I want you to pause and reflect and think of some real-world examples of functions that you're using every day.